Isdemir, Turkey's largest integrated iron and steel plant, continues to create value for our country for half a century. It produces approximately 5.8 million tons of flat and long products annually, with more than 700 steel grades. The transformation journey of ore to steel begins in steel production facilities. Liquid pig iron, produced by melting iron ore in blast furnaces, is transported to the steel plant by torpedoes. Liquid raw iron is weighed in the hot metal pouring pit and taken into the melting pot. Consecutive casting number starts here, and the whole steel production process is followed separately on the basis of casting number. The liquid raw iron comes by the ladle to the desulfurization plant from the hot metal pouring pit. Each ladle is treated specially, and liquid raw iron with very low sulfur level is obtained. Magnesium and lime are blown by means of a lance, taking into account the desired sulfur value in the final product. The sulfur element, which reacts with magnesium and lime, is separated from the liquid raw iron and forms a slag layer. The slag, formed at the end of the process, is removed from the surface by being drawn into the slag pot. Each scrap box charged to the converter is tracked by the scrap management system. External scraps are taken to the stock area after radioactivity checks. Different grades of scrap are filed into each scrap box, taking into account the steel quality to be produced. In special quality productions, a low impurity level is maintained by using clean scraps, such as process scraps and bonus scrap. After scrap charging, liquid pig iron is poured into the converter. The carbon ratio is reduced by blowing pure oxygen on the liquid iron surface at high pressure and flow. Precisely weighed additives allow unwanted elements such as carbon, phosphorus, and silica in the steel to pass into the slag. Metallurgical lime, which is needed by the steel plant and other units, is produced in the lime factory. Limestone is calcined by heating it to about 1050 degrees Celsius. A homogeneous chemical analysis is obtained in terms of steel cleaning by mixing liquid steel with argon gas that is blown from the converter bottom. Approximately 200 tons of steel are produced at the end of each casting process. Low-pressure steam and waste gas are obtained from the waste heat generated during the process. Waste gas is directed to power plants for electricity generation. Process parameters of each casting and additive materials used are managed and recorded with Level 2, Level 3, Level 4 systems. The final chemical analysis of the steel is set at the Ladle Furnace station. Temperature and chemical analysis are measured at entrance and exit. The raw materials used are weighed sensitively and added into the ladle. Homogeneous chemical analysis is obtained by mixing argon gas and liquid steel from the bottom of the ladle. The steel is heated to the required temperature for casting with graphite electrodes. Clean steel production is ensured by the application of calcium injection. In-flat products: API, X70, DP600, S700MC, structural steels, boron grades. In long products: welding wire, pre-stressed concrete wire, tire cord, carbon steels. On-blade free steel are among the steel grades produced. Undesirable elements such as carbon, hydrogen, nitrogen, and oxygen in the steel are removed. Liquid steel, which is sensitively alloyed in the steel melt shop, cast by the continuous casting machines for hot rolling process. In order to prevent the liquid steel from being adversely affected by the air, shroud tube from ladle to tundish and submerged entry nozzles are used during flow from tundish to molds. In casting, the casting speed is controlled by continuous temperature measurement. Production is carried out at the Continuous Castings facility, which has two different technologies for flat and long products. In the slab casting plant, the liquid steel is taken from the ladle to the tundish, and from there to the two-channel casting strand. Slabs are produced from 680 millimeters to 2,050 millimeters wide, with 225 millimeter thickness. Liquid steel, which starts to solidify in water-cooled copper molds, is transmitted to the segment area, where it comes in direct contact with water. Here, it is straightened with the help of rollers and cut to a suitable length according to customer demand. After the cutting process, deburring, weighing, and marking processes are carried out that enable the tracking of the slab. The finished slabs are taken to the stock area, managed by the automatic tracking system, and the casting process is completed. In the billet casting plant, 12 meters long billets are produced from 130 millimeters to 160 millimeter square cross-section, with the closed casting technique for special qualities. Primary and secondary water cooling and EMS systems in the mold provide a surface and microstructure suitable for rolling. The billets, cut to the appropriate size, are taken to the cooling grid. Each heat is taken to separate strands and transported to the billet stock area. As a locomotive power in the Turkish industry, Isdemir will continue its efforts to become the regional steel leader with production technologies that respect the environment and people for a sustainable future.